Exponent rules, exponential graphs, and functions. Let's start with third member. How can we write 16 using an exponent? It is 2, I can take a pencil, 2 times 2 times 2 times 2. So we can write it 2 to the power of 4. And 27 is 3 times 3 times 3. It is 3 to the power of 3. We already knew all this, so I'm skipping over it quickly. This is 5 times 5 times 5, so we can write it 5 to the power of 3. What was their name? X's name is base, 2's or other number's name is exponent or power. This is just example to x to the power of 2. We can say it x to the power of 3, 5, 6 or something. And the full name is expression. And we have a note here. The following rules only apply when you have the same base. We will learn some rules shortly. These rules can only be applied when the bases are the same. This is the must. Let's continue to the rules. Our first rule is product rule. What do I do? When we multiplying exponential expressions, we must add their exponents. Let's look why does it work. X to the power of 2 is x times x, and x to the power of 3 is x times x times x. When we multiply them, they are this is also x to the power of 5. This is the reason. Let's continue with the other rule. Power of a power. What do I do? If there are exponents inside and outside the parentheses, we must multiply them. This expression means x to the power of 2 times x to the power of 2 times x to the power of 2. So we can write it x to the power of 6 because if we have the multiplying, we should do addition with the powers. Let's continue. Power of a product rule. If there is an exponent outside the parentheses, it means that this exponent applies to both, so we must apply it to both. Let's look why does it work with an example. If 2x to the power of 3, this means 2x times 2x times 2x. So we will multiply 2, 2, 2, it will be 8, and x times x times x will be x to the power of 3. We should apply it to both. Let's continue. Quotient rule. If the bases are the same, we should subtract the exponents when dividing. Let's look why does it work with an example. X to the power of 5 over x to the power of 3. We can write it x times x times x times x times x, and x to the power of 3 we can write it x times x times x. Now we can simplify them, so answer will be x to the power of 2. We can easily do this by moving the base upwards like this. Let's continue with the other rules. Negative exponents. If there's a fractional expression, we can change the sign of the exponent and invert the base. We can give some examples like this. 1 over x to the power of minus 6 will be x to the power of 6. And also we can do opposites. 8 to the power of minus 8 will be equal 1 over x to the power of 8. We can continue with the other rules. Zero exponents, anything to the 0 equals 1. We can show that like that, but I want to change the color. X to the power of 3 over x to the power of 3. We can write it x times x times x and x times x times x. We will simplify the x's and it will be equal 1. This is the explanation. Let's continue with the last rule, I guess. Fractional exponents, we should write inside exponent goes on top, outside exponent goes on bottom. I can show you with an example. I want to change color. 9 root x to the power of 4. We can write it x to the power of 4 over 9. Or with the other example, square root x equals, there is 1 and this is 2. We can write it x to the power of 1 over 2. This rule was the last rule. Let's continue with the exponential graphs and functions. How can we understand that it is a graph of an exponential function? I will represent it with x to the power of 2. The same applies to the others. X to the power of 2. Sorry, it's not x to the power of 2, it is 2 to the power of x. Fx equals 2 to the power of x. I will show you. Let's do a table with x and y values. I want to change color again. First, let's find x and y values. If I write instead of x minus 2, y will be, I want to change color again, 1 minute. If I write minus 2, y will be 1 over 4. If I write minus 1, it will be 1 over 2. 0, 1, 1, 2, 2, 4. With these values, we can draw its graph. Expressions with an exponent of 0 are equal to 1. X is 0, y is 1 is here. This is our first point. X is 1, y is 2 is here. 2 and 4 is here. If we want, we can continue. If x is 3, it will be 8. It will be like that. No, it's not here. Three and 8. If x is minus 1, it will be 1 over 2, so it's here. Then 1 over 4 here, and it goes smaller, smaller, smaller. But it's never touch. What was the name of this? It is horizontal asymptote. Why will graph will never get 0? Our graph will be like this. it's continue. We can also write graphs domain and range with screen. Domain is x values. Graph can take every x values. It's continue to up and down. So domain equals x element of real numbers, positive and negative, all of them. But range equals y element of real number such that y greater than 0. We can also write graphs differences, first differences and second differences. This is 1 over 4, this is 1 over 2, this is 1 and 2. Like you can see, they are not equal, but for the linear equations the first differences are equal, but this is not equal. Let's look the second differences with another color. It is 1 over 4. I was right at 2. This is 1 over 2. This is 1, and it continue. They are not same again, but quadratic equations are equal for the second differences. Like or not says, in exponential functions the differences are never equal. That's all for today. Thanks for listening to me.